Hello students. In our previous video, we introduced you to a new word called discriminant of the quadratic equation, D. D can be calculated using formula b square minus 4ac. We also told you that there are three possibilities where we can find three different values of D. In case if D is greater than 0, that is it is a positive integer, the equation will have two real distinct roots. In case if D is equal to 0, in this case, quadratic equation will have real roots, but they will be numerically equal. And the third case, if D is less than 0, that is, value is some negative integer, then in that case, quadratic equation will have no real roots. And we asked you a question that is it possible to design a rectangular park of perimeter 80 meter and whose area is 400 meter square? And if it is possible, then find the length and breadth of such park. To solve this question, we will have to first frame the quadratic equation, find its D, and then decide whether is it possible to construct or design such a rectangular park. In this case, if D solves to a positive integer, then it is possible to design such a rectangular park. If D is equal to 0, then in this case, the value of length and breadth will be same, and so the park will no more be rectangular, it will be square. Or in case if D is less than 0, for this question, then there will be no roots and hence it is not possible to design a rectangular park of the given specification. So students, let's frame the quadratic equation and find out whether we can design such a rectangular park or not. Since a park is rectangular, let us assume its length to be L meters and breadth to be B meters. Now we have perimeter as 80 meters. We know the formula of perimeter of a rectangle. Yes, it is 2L plus B. So here 2L plus B is equal to 80. Therefore L plus B is equal to 40. From this equation we can have B equal to 40 minus L. Now we know that area of rectangle can be calculated as length into breadth. Therefore, area of park is equal to its length into breadth. Therefore, area of park, which we are given as 400, is equal to L into 40 minus L. Therefore, 400 is equal to 40L minus L square. Now students, shift 40L minus L square to the other side and we get equation L square minus 40L plus 400 equal to 0. Compare with ax square plus bx plus c equal to 0, which is the standard form of quadratic equation. And we get a as 1, b as minus 40 and c as plus 400. Now substitute these values in formula b square minus 4ac and calculate d. On doing so, we get d equal to 0. Now since d is equal to 0, it tells us that this equation does have two real roots, but they are equal. That is, the numerical values are same, which means length and breadth of this park are equal. And if this be true, then instead of rectangular park, it will become square park. So we can say that designing a rectangular park of given dimension is not possible. Now students, let us take one more variation of the same principle. Students, find the values of k for equation kx into bracket x minus 2 plus 6 equal to 0 so that it has two equal roots. Observe that its equation is not in its standard form ax square plus bx plus c equal to 0. So, first we will have to simplify it and write it in the standard form of quadratic equation. Therefore, kx into bracket x minus 2 plus 6 equal to 0 becomes kx square minus 2kx plus 6 equal to 0. Now we are given one condition, that this quadratic equation has two equal roots. What does this tell us? Take a pause and think for a second. Yes, I'm sure you must have got it. This information tells us that discriminant D of the equation kx square minus 2kx plus 6 equal to 0 is 0. Therefore, D is equal to 0. Now we know D can be calculated by b square minus 4ac. So therefore, it is also equal to 0. Now substitute values of a, b and c from the equation. Here in our example, comparing kx square minus 2kx plus 6 equal to 0 to a standard form, we get a is equal to k, b equal to minus 2k and c as plus 6. Therefore, b square minus 4ac equal to 0 becomes minus 2k square minus 4 into k into 6 equal to 0. On solving, we get 4k square minus 24k equal to 0. Now taking k common from both the terms on left hand side, we get k into bracket 4k minus 24 equal to 0. Transpose k to the RHS and we get 4k minus 24 equal to 0. Therefore, 4k is equal to 24 and k is equal to 6. Thus, the required value of k is 6, which means that if we put 6 in place of k in our given equation, it will turn out to a quadratic equation which will have two equal roots. We can verify this by solving the equation so formed. And we find that it has two real roots which are as on your screen.